Welcome back to the second video for TEC 293 on Tuesday, April 20th. The purpose of this video is to review the instructions for Lab 9. Lab 9 starts on page 97 of the lab manual. So that I can show the instructions, I'm going to switch over to the document camera. These are the last couple of pages in the lab manual, so I guess that means we must be getting really close to the end of the semester. So let's talk through Lab 9, starting on page 97 of the lab manual. So the equipment that you're going to need, obviously the Instron machine. We're going to have 8 of these wood blocks, and like I mentioned in the first video, I'm going to glue these up so they'll be ready for you when you come in on Thursday the 22nd. So I'll use 4 different kinds of glue. I haven't decided yet. I don't know exactly which kinds of glue. It depends on exactly what we have. But I will glue them up so that they are in the shape that is described here and that we also talked about in the first video. Each one of these blocks is 3/4 of an inch thick, and it is 1.75 inches in this dimension and 2.0 inches in this dimension. So I'm going to glue them up like this so that there is about 1/4 of an inch offset on this side right here, as well as on the other side right there. So I'll get them as close as I possibly can to 1/4 of an inch offset. We're also going to need 4 different types of adhesive. Like I said, I will select the different types of adhesives based on what might be interesting and also what we have available down in the lab. And then you'll also need a ruler. You will actually need a ruler, but I will provide that to you when you come into the lab on Thursday. You need a ruler because you're going to measure the actual dimensions of the wetted area, the glued area, because that's important for calculating the shear stress. All right, so like I mentioned, I'm going to do part A for you just because it would be too much of a hassle to bring all of the groups in and then have you glue these up. To have you come in just to glue these up would seem like a waste of time. So I'm going to do the gluing and then you'll do the testing. So we're going to take 8 of these pre-cut blocks. We're going to decide what adhesive we're going to use. And we're going to label the blocks because otherwise it's really hard to tell which one was glued with Gorilla Glue and which one was Elmer's glue and so on. So I will label the blocks with the type of glue that was used. And then there needs to be 1/4 of an inch offset, like I said. So that means that when I glue them up, I'll glue them up like this so that as best I can, I'll get real close to 1/4 of an inch right there, as close as I can. Also, okay, what else? Yep. Yeah, it also says make sure that the force is applied parallel to the grain direction. So all of these blocks are cut with the grain going in the short direction so that when we glue them up like this and then we install them in the test fixture, the force will be applied in this direction with the grain. And that's important to get a good, reliable test of the glue so that the block of wood doesn't fail prematurely. All right, and then when you come into the lab, I do want you to measure and record the actual dimensions of the shear plane. This is the surface area that's wetted by the adhesive. So when you come in, you're going to measure this dimension from right here to right here, and also from right there to right there, because that's the area of the adhesive. So when you calculate your shear stress, you'll need to know that area. All right, so I will do that ahead of time. Then when you come into the lab, the Instron lab, on Thursday the 22nd, then you will do part B, the testing. So the test setup is really the same as all of the other Instron labs. You're going to raise the upper part of the test fixture. If you remember that guillotine type lab fixture that I showed you in the first video, basically you're going to raise up the guillotine part, the sliding part, and then slide the glued up specimens inside there so that this part is resting on the fixed support that doesn't move. And then the slider, the guillotine part, will come down right here and apply a force on this side right here. Next, you're going to go to the computer and you're going to click on the test procedure that's called TEC 293 adhesive shear testing. And then you'll run the test very similarly to the way that you ran the previous Instron tests. Make sure you balance the load and zero the extension. Those are really important steps to make sure you get valid data. And then after you've done that, then you can press start. And the test is going to run. It's going to stop the test when it detects any of these three conditions. When the block of wood has deflected by 0.2 inches, like that much, you know, it has failed. The adhesive has failed when it has deflected by that much. So that's 0.2 inches. It'll stop if it gets to that. It'll also stop if it detects a 40% drop in load between successive data points. That means that you had a sudden failure. So in that case, the test will also stop. Or this is not going to happen, but if it does detect a force of 20,000 pounds force, if we got some crazy, amazing glue and it actually does reach that force, then it will stop to protect the machine. Okay, it'll tell you when the test is over, then you'll press OK, and then you'll click Finish at the lower bottom right of the screen. That'll save the data. And then I will upload the data files to the Resources tab in RegNet, just like I have with the previous labs. And then you'll repeat that procedure for each of the 4 specimens. And I do want you to take a picture of these broken specimens. So that after they have failed, I want you to take as good of a picture as you possibly can to show how it failed. So that way you can describe whether it failed via cohesive failure, adhesive failure, or substrate failure. So don't forget, step 17, take pictures of your broken specimens so that you can include them in your lab report and discuss them in your lab report. Then we get to the results section. And I want you to make a plot of the load versus deformation for each of the 4 specimens. Label all the axes with units. The horizontal axis should be the deformation, just like we have been doing. You know, strain has normally been the horizontal axis. Strain is kind of analogous to deformation. And the vertical axis should be the force measured in pounds force. So basically here, you don't have to calculate stress or strain. So that's a nice thing. There's no stress or strain calculation, at least when you're doing the plots here. I do want you to label the point in the plots where failure occurs. There will be a failure somewhere. So pick out the point and label it where failure occurs. And then of course, identify the figure by labeling it with a finger number and a brief description. Then I also want you to make a table that shows the maximum force in pounds force that was achieved by each specimen before it failed. So that way you can tell which one is the strongest of the specimens. And I want you to calculate the maximum shear stress. So to do that, you'll use the maximum force that it achieved and then divide by the shear plane area. So you're going to use this data in step 3 when you calculate the maximum shear stress that each specimen was subjected to before it fails. Show your work, or at least describe what you're doing when you calculate the shear stress, and then make a table comparing the maximum shear stress that each specimen had before it failed. In the last part of the results section, I want you to make a bar graph just for visualization. It's easier to visualize it in a bar graph than a table. So I also want you to make a bar graph. Show me the maximum shear stress. That should be on the vertical axis in PSI. And then on the horizontal axis have the different specimens, and identify which specimen is which so that it's easy to tell, okay, specimen 1 was, for example, I don't know, Elmer's or whatever it actually happened to be. Make sure it's clear in the plot what each specimen was. Then in the discussion section, number 1, I want you to summarize your findings. And to do this, refer to your plots or your tables or graphs up here so that you can justify your answers. So tell me which adhesive was the strongest, which one was the weakest, which one was most ductile, which allowed the most deformation before it failed, and which one was the most brittle, which allowed very little deformation before it failed. All right, make sure to answer all of these in complete sentences, by the way, just like normal. In number 2, identify the failure mode for each specimen, whether it's adhesive or cohesive or substrate or some combination. Oftentimes you'll have a combination of modes for an individual specimen. So explain how you know. So I don't want you to just say specimen 1 failed by cohesive failure, specimen 2 failed by adhesive failure, and so on. I want you to explain how do you know that specimen 1 failed by some type of failure and specimen 2, etc. So explain how you know how each specimen failed, what tells you that it failed via, for example, cohesive or adhesive or so forth. And to do that, to help you do that, I want you to include pictures of the broken specimen so that you can refer to it and say, as you can see in figure 6, we can see that we saw this that results in substrate failure, or so on and so forth. So you can describe it by referring to your figures, which are your pictures of your broken specimens. In discussion question number 3, now that you know about some of these adhesives and the strength of the adhesives, which adhesive would you have selected in lab 8 to make the strongest beam possible? So basically, in lab 8, you kind of had to guess. You just had to use whatever glue, what was available, and your intuition on which is going to be the strongest glue. But now we have some data. So using that data, which one would you have selected for lab 8 and why? And then finally, I want you to do a little application here. So pick 2 of the adhesives that we tested in this lab, and then give one specific example of where you might use each of those 2 adhesives. What would be a good application for each of those 2 adhesives from this lab that you select? Explain why you would select those adhesives for specific applications. And you can consider lots of different parameters like strength and ductility. You can also make some educated guesses about price and cure time and how available it is, and you can see what color it is and so forth. So use that information and tell me where you might use 2 of the glues that we tested in this lab. All right, that's it for the instructions for lab 9. So as always, let me know if you have any questions, and I'll see you in the lab.